If you like this video, don't forget to subscribe and share. Historic achievement. Check the instantaneous transfer of information over the internet for the first time. Western University elementary engineers and the success of the instantaneous quantum construction via fiber optic cable. Western University elementary engineers and the success of the instantaneous quantum construction via fiber optic cable. The traditional path that uses cars and large trucks tries to exclude your transmission to remove excessive sensitivity, but for example, a glass ball, and this can shatter if it hits anything in the way. This is how the information began. It is very sensitive, and noise or interference may spoil it. The problem that a research team from Southwestern University began to solve, and they were able for the first time to achieve a new breakthrough for instantaneous quantum transfer of a small enough information from 30 kilometers via the same original path, which is the optical cable in which traditional internet data was tested. This achievement was announced in the journal Optica, because it contains, or its data, as they know it, is a completely new and different type of information that you use in everyday life. Traditional information, such as that used in computers and phones, is based on bits, which are the basic entities of the company, and take the value 0 or 1. In contrast, information starts on a new principle called quantum superposition, qubits. And the big difference is that quantum superposition can be in a state of 0 or 1 or in a different state at the same time, and special cases are called quantum superposition. To illustrate, imagine that you're playing a coin flip game. In traditional information, when you flip the coin, the result is either heads, 0, or tails, 1, but in quantum information, the coin can be in a state of heads and tails at the same time until you measure it or observe it, and then it turns into a specific result, heads or tails. Quantum information in this form opens up entirely new possibilities in the field of computing and communication. For example, in quantum computing, quantum computers can process a large set of possibilities at once due to the property of quantum superposition, which allows them to solve very complex problems much faster than conventional computers. Computer engineer Prem Kumar said that what they have achieved shows a path towards quantum networks and next-generation classical networks that share a unified fiber optic infrastructure. The challenge of transmitting quantum information. But the big challenge facing the transmission of this information is its sensitivity to any noise or interference, because it depends on unique properties of quantum physics. When quantum particles are entangled, any change in the state of one of them directly affects the other, and quantum information depends on the superposition of particles in several states at the same time, and any interference can lead to the loss of these states. As the distance over which quantum information is transmitted increases, it becomes more susceptible to change or loss due to interaction with the surrounding medium. Because of this sensitivity, it was difficult to send quantum information through the same cables that traditional internet data passes through without being affected by the noise caused by the data. The solution that researchers previously succeeded in was to prepare special cables for quantum information, but they were very expensive, and they did not reach the point of using them to achieve long-distance transmission, in addition to the fact that their generalization requires extensive modifications to the infrastructure. The main advantage of the new breakthrough is that the researchers succeeded in transmitting data over a long distance, 30 kilometers, through the same traditional path, which is traditional internet cables. This achievement has many advantages, the most important of which is that it did not require any infrastructure modifications, and it achieved the potential of quantum teleportation without incurring additional costs. Transporting quantum states over long distances proves that quantum communication networks are not just science fiction. To protect the state of the photons carrying precious quantum information against the 400 gigabit per second internet flow, the team of researchers used a variety of techniques that work to reduce the risk of photon scattering. Scattering is a phenomenon that occurs when light waves, such as photons, undergo unwanted changes as they pass through optical fibers. The team studied how light is scattered in the fibers, and by carefully adjusting the transmission conditions, they were able to reduce this scattering. They succeeded in placing the photons at a precise point in the optical fibers, meaning that they carefully chose a specific location where interference and scattering could be minimized. With the limitation of only the speed of light, quantum teleportation offers a new, super-fast way for fast and secure information sharing. This is achieved through quantum entanglement, where two particles become linked so that the state of one affects the state of the other instantaneously, regardless of the distance between them. By leveraging this entanglement along with classical communications, the quantum state of a particle can be reconstructed at a distant location, effectively transmitting information. What we have achieved demonstrates a path toward next-generation quantum and classical networks that share a unified fiber optic infrastructure and represents a major step toward realizing a long-standing vision of building a communications infrastructure that relies on the unique properties of the quantum world, said Prem Kumar, a computer engineer at Northwestern University who led the study, in an official press release from the university. Transporting quantum states over long distances proves that quantum communication networks are not just science fiction, but an achievable reality.